Welcome to the Explainer. So today we're diving into a really fantastic developer journal entry by Ang, written back in June 2026. And honestly, it tackles a problem that anyone who's ever worked with document formatting is going to instantly understand. We're talking about taming completely messy, inconsistent ebook data, and doing it all using some incredibly elegant Haskell data structures.
Think about your own projects for just a second. How do you usually fix messy chapter alignments when you're generating documents? I mean, it can be an absolute nightmare, right? Just a total mess of edge cases and wildly varying text lengths. Well, let's really dive into this, because this exact question was the whole catalyst for today's code exploration. Ng was deep into the trenches of generating ebooks and just ran headfirst into a brick wall.
Here's what was going on. The main objective was to generate ebooks, specifically putting together PDFs. But there was this incredibly frustrating visual bug popping up. Whenever the PDFs were generated, the table of contents formatting was just completely inconsistent. The visual alignment was all over the map, which, totally ruins the reading experience for the user.
So what was actually causing this? The root cause literally came down to Chinese chapter numbers. Because these characters vary so wildly in their physical structure, they were just completely throwing off the entire alignment of the page. To get that crisp, professional look we all want, these unpredictable characters absolutely had to be converted into uniform, standard numerical digits. No way around it. Now, to handle a conversion like this effectively, you can't just blindly hit find and replace. That's just going to break things. You actually have to take a raw, totally unstructured string, like the one we're dealing with here for chapter 300, and figure out a clever way to break it apart so the system actually understands what on earth it's looking at. To really tame this chaos, Ng systematically deconstructs the messy string into 5 distinct, super manageable components. Step 1 is isolating the prefix, that very first character. Step 2 is extracting the actual number that we care about, in this case 300. Step 3 identifies the unit character, which basically just means chapter. Step 4 pulls out the colon, acting as a separator. And finally, Step 5 captures the descriptive suffix, which is the actual title of the chapter itself. By slicing the string up this way, a massive formatting headache suddenly becomes a neat set of solvable, bite-sized pieces. But, we're working in Haskell here, which means we need strict, reliable types. So to capture all these newly dissected text pieces, Ng introduces a brilliant conceptual code solution. Enter the header info data type. This is a brand new Haskell structure designed specifically to store these parsed segments of a numbered or even a keyword chapter header. We're basically taking raw, unpredictable text from the wild and giving it a strict, incredibly defined home in the codebase. Let's map this all out to see how the approach actually takes shape. We can take our real-world text components and seamlessly translate them directly into corresponding Haskell fields in our new header info type. It is just a beautiful one-to-one translation from chaos right into structure. The prefix becomes high prefix, the number becomes high number, the unit maps perfectly to high unit, the separator goes straight to high separator, and the chapter title itself slots perfectly into high suffix. Now, the absolutely crucial point here is how these specific fields are actually typed in Ng's code diff. Notice that the prefix, the number, the unit, and the separator all use the maybe type. This just means they're optional, right? They might be present in a header or they might not be. However, the descriptive suffix, high suffix, is strictly typed as text. There is no maybe there. And that tells us the system expects every single header to at least have a descriptive title, even if it happens to be missing a number or a prefix entirely. And just to give us a little bit more context on how this whole thing fits into the wider application, Ng also briefly highlights the header type structure. This simple data type just defines whether the parsed header metadata we're looking at belongs to a volume, a chapter, or a keyword. It's a pretty small detail, but it's absolutely essential for organizing the final ebook properly. Okay, so let's see how this builds right into the core of the document parser. The overarching document body's block type is elegantly updated here. The block header variant used to just take a header type, an integer, and some text. But now, it's updated to seamlessly incorporate this shiny new header info metadata right alongside those original parameters. The entire data model is suddenly infinitely richer and just perfectly structured to handle the crazy complexity of Chinese chapter headers.
Which, of course, brings us right back to our ultimate goal. With the text now cleanly structured and living safely inside our header info data type, we have successfully isolated the text numeral. Awesome, but we aren't quite done yet. To actually fix our table of contents alignment, the next crucial step in Ang's process is translating that isolated text numeral into a standard numerical digit.
And honestly, that brings us right to Ang's cliffhanger. We've built the perfect structure, but how do we actually convert these parsed Chinese numerals into standard digits using Haskell? What kind of logic is required to reliably turn those very specific text characters into actual numbers? Well, we're going to have to wait for Ang's next journal entry to find out for sure. But until then, I want to leave you with this to think about. When you face a chaotic wall of raw data in your own projects, what data structures can you start building today to elegantly tame it tomorrow?